All right. Hello, everybody. Today in Dallas is the 12th of October, or the 13th of October around the globe a little bit. You are viewing Robot Builders Night Virtual, a regular Tuesday night occurrence of the Dallas Personal Robotics Group. We'll just do the usual thing and saunter around the table and talk about our current robot projects and the like. So we have on cue, we have Michael I starting off, and then Murray from New Zealand, and then Pat has a question about free RTOS. So let's dive right in and see where the discussion goes.
I might need to not be second. I just introduced a bug.
Okay. We'll just have to adjust things.
Working feverishly.
No, we can juggle. Anyhow, we'll put Mr. Doug P ahead of you since it looks like his precondition is met. Mr. Anderson is online now, so all good. So Michael I, without further ado, the floor is yours.
Awesome. Do I need to do a presentation? I want to present now, or
however you'd like to show it.
Do you blow it up, or do you? That's the entire screen. I don't know what's going on here.
Would you like to show something on your screen or something in your
hands? Yes, I do. I want to blow it up.
So on the bottom, there should be of your screen a little box with an enclosed arrow pointing up. If you click on that, then what you want to do is share your entire screen or a window.
Why won't it let me share the screen? It says can't share screen.
Can you share a window instead?
To share a screen, you have to actually click on the one that comes up.
No, I just minimized myself. Well, there we go. Y'all see me?
Not your screen.
Okay, well, what do I work on? Let's see here. It says present, and it says you must grant permission in order to share screen. Maybe some of that.
Sounds like a browser issue, maybe.
Sounds like, yeah. You can't do that.
Check the top of your screen. There might be a little dialogue asking for permission.
Let me try this. Man, this ain't right. I'm all ready too. Let's see. Present a window. You must grant from I ain't gonna let me. I can't really show you. Y'all can see me in a small.
Well, we can pin you so that you're big.
Yeah, would you do that?
Yeah,
I can't do, it won't let me. It's a browser issue. Must be one of these Linux issues. I'm running Linux. So, let me move my camera. Can y'all can make me bigger?
Yeah, we have.
All right, so here I am. That's my claw machine. Some of y'all have seen it before. Do y'all remember that at all from last year?
Oh yeah.
Okay, so I made an improvement. You see up here this pad on the end of the claw?
Mm-hmm. Yep.
Now, Doug, if you remember the do you remember when we had the club robots project, and you had a bunch of STL files on the internet that you could download? That claw is from that. The claw itself.
Okay.
Yeah. Anyway, but I modified this. I've had this last year. This claw machine is I made it to take to Halloween carnivals. My Halloween carnival at church. Y'all seen it. So I got it back out again this year, and I made 2 modifications to it. So this one I changed this pad, and I'll show you here in a minute what I changed it to, and I'll show you what it's made up of. But I take it and I designed this claw machine to pick up, to win, not to lose like the ones you get at the arcades. So I designed it so the kids could win and move on at these carnivals. There we go. Looks like we're gonna pick up a stuffed animal. Did y'all see that?
Yep. Yep.
That is so anti-American. It should be competition, man.
The competition was building it. So anyway, there we go. So I just wanted to show you that these pads are new this year, and I want to show you what the difference is from last year. I'm gonna move on one of these days and start building something different. So this is what we had last year. I had these in here like this last year,
Okay.
and they didn't catch very well. You see that? They were kind of really goofy actually. But I added these pads. I added this pad and I put foam on it with some sandpaper on the edge. See how that stick? And so when it grabbed that, and I thought, well, what made me think of this is I go, how do we grab stuff? And I noticed I did my finger like this, and I go, well, that's soft. And then not only is it soft, we got fingerprints that help us grab stuff. So I kind of got that off of that idea. And then I made this a little wider, and it grabs almost every time. So anyway, that's an upgrade. Also, this Halloween, I'm going to add this sound trigger, MP3 sound trigger from SparkFun, and I'm going to put some sound effects to this thing. So that's what I wanted to show off this week. I haven't done this yet, but maybe next week I'll have some sound effects set up and I can show you that. So that's my deal.
Starting to get pretty slick.
I know. And then I'm gonna move on. Next year I'm gonna start designing a claw machine that works like it's a robot arm that will swing inside a container like that, 180 around, and then when they push the button, I think it'll drop like this does. But nevertheless, it'll be a little bit different and simpler to tote around. I'm gonna try to start that
I
problem.
think you're gonna need a couple of sound bites. One, you need that incessant ding 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 from every slot machine in Vegas. You need one of those things that's moving. And then if you can detect if they won, you need like a hallelujah or hooray thing. And if you can detect if they lost, maybe you want a big explosion, like somebody just blew it up or something. You know, and suggestions. You know, because
Well, I can. Let's see here. Let me show you one of the sound bites I think I'm probably going to use. Just one. Where's that at? Let's see. Oh, here it is. Y'all hear that?
there you go.
That's one, and then here's another.
Oh, that's appropriately annoying. Yeah.
I like that one.
Oh yeah. So I'm thinking about trying to write a script that's random, so that we don't have to listen to the same noises for 2 hours. So they'll change up a little bit. So anyway.
I don't see a problem with that, but others might. I can see how they might. So.
Well, Michael,
Anyway.
you actually turned on a robot and it moved, so you get this evening's gold star.
Oh yeah.
Thank you. Next week, maybe it'll make sound. So anyway, I'm done.
Nicely done. Very good. Thanks. Yep.
Yeah, you talk about annoying sounds. John made this, I don't know, gadget that basically played like a xylophone. And we took it to the Tyler Maker Fair, and that thing went on for hours.
Yeah, but it played more than one tune. But it was. I mean, by the end, and I was thinking that if you have 2 hours of and all that other, you're going to be well crazed. Yeah, that was John's xylophone. God.
Alrighty.
It was cool though. It brought in a crowd.
Yep.
You know, but boy, it just drove the person in the booth just went nuts. So
I find that every bit of booth duty tends to drive me nuts, so it doesn't matter what's there. But All right, so Doug, I think we've met your precondition. Are you good to go?
Yeah, I'm good. All right. Okay. Let me, I'm going to present here.
David, you have to pay attention because he wouldn't present without you here. So.
Yeah. Okay. Boom. Okay. David said, hey, I hadn't shown obstacle avoidance. All right. So this is the current state of obstacle avoidance. And I got to admit, I've been working on it a little bit. So it's actually better than it was when I talked about it. So this has been sped up 150%. That's why it's so jerky. So first I'm just showing, okay, there's where I'm going to go. There's no obstacles. This is just a straight, go straight. And, okay, so it's just going to go straight. No big deal. And you can see the PID's a little overtuned, but that's okay. I'm not worried about that in this. So, there goes, stop. All right, no big deal. All right, so now I'm putting in a simple narrow obstacle in the middle, straight in front of it. Okay. Now it's using temporary waypoints and it's triggered at, I think, 18 inches. So no problem. All right, now this next test, I've added a box behind the target. And what it's testing is that you don't want your obstacle avoidance to keep you from going to your target. And why did it go this way this time instead of the other way? I have no idea. I mean, I know the algorithm, but for some reason it has a mind of its own. All right, so you can see that having an obstacle right behind it doesn't bother it. All right, so now we're getting a little more interesting. Okay.
Bravo.
Yeah.
Impressive.
Yeah.
Well,
Well, wait a minute. I'm going to try and see here.
But wait, there's more.
There's more. There's a lot more. Okay, so I've moved this back. And guys, the one thing that I couldn't guarantee was which way it was going to turn. I was trying to make it turn where the two boxes were, and I know it's not going to do it. Yeah, see? And since I moved that other box back, it's going to shoot through well, no, I guess it isn't. It's going to take the long way around. I'm not using any mapping in this. This is just straight obstacle avoidance with temporary waypoints. Okay, you see I'm getting to move this guy back, hopefully get him to go the other way. Oh, so he turned this way. All right, and this is where he found it. He found the hole between the two boxes, which I didn't even know was there. I was thinking it would go around that outside box, but nope, it found a hole.
How do you decide how far to go beyond an obstacle?
This is really serendipitous. I just picked two values, and I picked an angle of 45 degrees, and I think a distance of 2 feet. So it went the other way. So this is not too interesting. So it's starting to get a little upset with it now because it wasn't doing what I wanted it to do. So, let's see, oh, can I move this box up close, force it to go the other way? So we still haven't seen it go around 2 boxes yet. Damned it didn't. So it hit it. So it's not perfect.
Can you set up the boxes so that it'll oscillate between 2 locations?
Well, I actually have some code that's supposed to keep it from doing that. All right. But I will show, there is, in the end, I show a failure mechanism. Let's see. Damn. At this time, I'm getting really frustrated. So there it clipped another box. Okay, finally got it to go the other way. Chunk. All right. Okay, so now I've put a third box over here. Hopefully it'll turn that way. You know which way it's going to go, but we hope it's going to go that way. Oh, good. Okay, it did go that way. So here goes.
Doug, using IR or sonar or LiDAR?
Nope, this has got, well, it's got those Pololu 471s and one DF Rover Ranger. So right now, the primary, it's only using the center. It's only using the center to get, to detect obstacles, but it does use the left and right to determine which way to turn. All right, so that was pretty cool. So let's see what we got here. Is there anything different? Okay, here's it going the other way. It caught that box pretty good.
Doug, do you have any side-looking sensors that you can use to tell you when you're clear of the obstacle?
I don't even have bumpers, David. So yes, I do have side, and I'm going to talk about that in another slide here. Okay, let's see. Is this the? All right, so we're going to go. This time I've actually added a fourth box to see if it would narrow the gap through there. You see, there's the fourth box. It didn't bother it at all. All right, so all that's cool and good. So now I've decided to try to make it fail. So you notice I've moved the 2 boxes up close. So it's really kind of trapped. All right. I mean, yeah, you know, in theory, it could go around that one box on the left, but let's see what it does. And here you see that classic problem that David was talking about. I'm going 180 degrees from the target. So going back towards the target because my temp waypoint didn't find any obstacle. And I'm just going back and forth, okay? And you can see, I said, well, maybe it'll oscillate its way out of this thing. But the answer is no. Well, so here it's different, but it's still going 180 degrees. So even though, so if it gets times out a temporary waypoint and is going 180 degrees, it'll automatically head back towards its target. So it gets in this going back and forth. So anyway, So this is the case of it failing. And I'm going to do something here. I'm going to step up on it. So I'm going to try and make it do something different. And watch this. This is kind of interesting. What did it do? It aimed right straight at the target, came back over here, saw this one, and it goes 180 degrees again, or almost. So anyway, so just to see what else happens if I can force it to go. So I'm going to make one more intervention here. Okay. So, come on, Doug, do it. When you're watching the robot yourself, it's not so boring. You know what I mean? So, okay, here I am. I think I'm forcing it to move in a way that's different. There it is. This is where okay, so I see I've repositioned myself. So now it's going around this wall. So it's no longer trapped. Because when it turns towards the goal, there's a wall in front of it. And you can see it going over the side. And okay, now once it gets here, it's just the standard problem that it had before. Should be no issue. And it isn't. Okay. Now, and boom. All right, I think that's it. Okay. Now I'm going to, let's see. Okay. So here's my next steps. The first thing I found, and I'll show this a little bit later, I'm going to add a bumper because when I'm at a very acute angle, the IR and sonar sensors fail. There's got to be, they're not sufficient to detect an obstacle. Then I'm going to try to add some random components to the turn angle and distance, detour distance. And I may also add distance to obstacle zones. Right now, I've only got one zone. So once it picks up an obstacle at 18 inches, it just does its thing. But you could have one at 24, you could have one at 12, whatever, to create different behaviors. And then I'm also thinking about a maneuver. So I'd trigger a maneuver if the heading is between 165 and minus 165. Now that's not degrees in a direction, it's degrees from where the target is. So if it's actually opposite of the target, it'll kick off a trigger maneuver, which will hopefully direct it into different things. Then I'm going to go ahead and bring in the additional sensors. Right now, I'm just using the center, left, and right, but the right and left are only doing direction and the ultrasonic. I'm going to make it independent right and left, and I have the 45s and 90s available to me. Okay, then this is an idea that I think has a lot of promise. I'm going to capture history of the previous travel. So I'm looking for being stuck. One idea is to use the target circles of previous temporary waypoints and can restrain movement to the same circles. Otherwise, you won't go back and visit a previous target. And I'm thinking about an array 5 deep. And then another idea is, this has to do with these, what do I put in the array? Well, I could put the X and Y coordinates of the temporary waypoints, or I could put in the heading angle of the temporary waypoint, or the heading and target distance. So I'm not sure how I want to populate that array yet.
Hey, Doug?
Yeah.
Maybe that array, it might be helpful to capture if at some point you decide to turn all the way around and go backwards, that knowledge might be helpful. That if you did that turn once at that location, then did it again at that location.
Yeah, that's what I'm. So this one up here, this heading between 60 minus 65 and 165. And this one, I think, may actually be the thing that overcomes it. But I'm going to be playing with some of these other ideas too. This is a brainstorming session. And then I guess to decide what to do when it's truly trapped. So I'm thinking there, if you're moving somewhere and you're trapped, then that means one of the obstacles is not fixed. So you're just going to keep searching. But, and the idea was, well, you know, maybe I go do a wall following mode, but you still need to know if you're stuck or trapped. So I'm not sure. That was just to let, you know, try for completeness. So now this is the challenge. Okay. So I'll see how I do this. No, don't do that. Okay. So here we go. So this is without obstacle avoidance, multiple waypoints. You've seen this before, and you can see I was real sloppy when I started it. See how it's drifting off that one straight line? That's because it started off at an angle, but it's going to make it. And what I'm doing here, since, you know, my wife really doesn't appreciate me keeping little pieces of tape on the floor for months, I'm really trying to establish where the target would be if I did it with waypoints. So this is just going to waypoints. This is what I want to be able to do with a single waypoint. And I don't know if I can speed this up.
Doug, I have a suggestion. Why don't you use some kind of colored tape that looks exactly like the floor?
Well, I think that's an idea, but then I probably wouldn't be able to find it myself. Now,
how good is your wife's eyesight is, I guess, what I'm asking.
She's good enough.
Okay.
All right, so here, all this is doing is establishing where I want to go. And if you remember, go back to that previous video, you would see that this is pretty straight on. All right. So even though this waypoint obstacle avoidance is not really strong yet, it was worth trying this. Okay, so it's going to stop up here. Okay, so that's where I'm going to put a red cone. All right, so now this is with obstacle avoidance. So the first thing it tries to do is go towards the cone.
So Doug, when you say this is with obstacle avoidance, you mean and with also only one waypoint?
Yes, only one waypoint. So it's kind of bouncing around because when it runs out of its detour distance, it turns towards the robot, towards the target. And if it gets triggered, then it will turn around. And we're coming up to an interesting problem, and this is why I want bumpers. All right, what would be the worst type of target you would go up against? Okay, how about an acute angle with a shiny stainless steel garbage can? I think you're going to see that? Nope, you're not. And then eventually it turns itself so it does see it. So always turning back towards the target. And Doug loses his cool here. We're not going to listen to this. You don't hear anything. There's nothing going on here. No. Okay. I think I got over that. So,
Doug, it's all right. We're not hearing the recording audio anyhow.
Okay, good.
You could add whatever soundtrack you want. We would believe you.
Okay, well, let's just put it this way. Doug thought he lost it there.
How about, sounding, you had the casino. How about
you know, and play that from the animal zoo thing or something.
Yeah.
So you're always turning 45 degrees?
And it's, well, if the temporary waypoint can be re-triggered multiple times. All right, and I'll show the code here in a second.
Why don't you just start looking at the thing that is the obstacle and
That
continue
is a good
turning
idea. Yeah,
until
no,
you don't see it anymore, and then that's your heading, and then
that
you
was
just
my
head.
original idea.
And that got
This one is easier to implement.
yes.
And so that's how close it got. I call that a win. So anyway.
A lot of gold stars there, Doug.
Yeah. Now, okay. Well, is anybody interested in this, or I'll just quit here? You want to see this last one?
Nah, we were bored for this whole time. So
I want to see it.
screw it up, man.
Okay. All right. All right.
Show us code.
Okay. So this is looping through. Okay. And in a normal loop, it would create, I think it does the odometry check, then it does a target distance check, and then whatever, and then it sets the PID and goes on. This sits in front of that. So what this is, it checks for a center obstacle, and it's using the center 4071 and the ultrasonic and the targeting type. And it basically asks, it asks is, if the target distance is less than the center, the center, the ultrasonic, or well, this one actually is wrong. It's the same. It should have been here, the CO471. So that's a code error. I'm glad I looked it over. So anyway, so what that does is that's the part that handles, you've got a cone, you've got an obstacle at your target. That's what handles that one line of code right there. And then if you have an obstacle, then this bit flag is not going to be equal to none. For a center one, it will be equal to 4. So in that case, it looks, have you reached the fail count limit? Otherwise, you can't just trigger off of one detection. Right now, I think it's using 5 detections. It has to detect 5 in a row for it to kick off. And what's this one? Hitting error. Oh, and this is important. So since your loop is over 20 milliseconds and your robot's not turning that fast, the other thing you do is you don't proceed until your previous action, your previous temporary waypoint, reaches within 2 degrees, or actually it's whatever you set this limit to, of the target heading error. Now remember, the target heading error is not the original waypoint anymore. It's the temporary waypoint. The targets for the original waypoint have been stored in the structure of the temporary waypoint. So that means that you have to fail a certain number of times, and your robot has to have a heading error of less than 2 degrees. If that's true, and then this is just saying it's a center obstacle. And the reason for that is because I would potentially add more lines up here, like check for left obstacle, check for right obstacle, whatever. So in this case, so then it looks if the right distance, remember now, you saw how my sensors on the forward are tilted in. So the right's really looking left and the left is really looking right. And I decided to keep the convention with the actual physical sensor location and not the direction it was looking at. So in this case, it's saying you want to turn left or counterclockwise. Now this little bit right here, I'm not going to go over, but I will tell you that this is what keeps it from ping-ponging. This little bit in here. You can look at it later. Else, and so then what it here says, I'm going to go minus turn angle, which is counterclockwise, and it also sets the previous turn to counterclockwise. If this condition fails, then it goes the other direction. It turns clockwise. All right. And then since you've successfully created a temporary waypoint, it sets the fail count to 0. And then this is what keeps the fail count. So like if you had I detect, whoops, I didn't detect. This one sets it, de-increments it. I told you had to have 5 in a row. It really, yeah, I think it's still true. Otherwise, if you fail, it counts, the fail count goes down. And that's the whole thing. That's the whole obstacle avoidance on this robot. That's it.
Hey, Doug, what controllers are you using on that robot?
What controller?
Yeah, microcontroller. What runs that?
Okay, I'm using a Mega on this one.
Oh, okay. You don't like have a Raspberry Pi or anything like that on there? That's all done with Arduino?
It's our Arduino, yeah.
Wow.
Yeah. So anyway, that's the state of it. I know I have some fail mechanisms, and I think that I'll probably polish this one a little bit more. How transferable is it to my outdoor robot? I guess it should be. The big problem with it is I don't have turn radius, so I don't know. It may not be very, but for little differential robots, it's pretty transportable. Okay, so that's about all I had to say.
Nicely done. Gold stars, Doug. Look at that.
Okay. So now they can't say I didn't obstacle avoid again.
First 2 tonight, and we have multiple gold stars. That's pretty awesome. All righty. Okay, well, next we have Pat with a question about free RTOS, and then Murray, if you're still not quite there, almost there, a little more longer. Okay, so after Pat, if somebody else wants to jump in, we should have some time there. But Pat, well, why don't you raise your question? What's going on with free RTOS?
So I've been working on my motor controller for the Wooden Monster, and I'm rebuilding it since I took the one out for my outdoor bot and used it. So now I don't want to take apart the outdoor bot. I'm rebuilding a new one, and I'm using an STM32 Blue Pill as a controller for the motor driver. And I started playing around, and I said, well, what if I put RTOS, free RTOS on it, to say, well, let's do a little bit of time sharing and have it go through and let it take care of the 50 millisecond loop to go through everything with all the different parts of the routine. And then have a routine for like a main routine for encoders to read encoders and take care of the stuff that's continuous. So doing that, I was playing around, and I'm getting an error. And I'm going to share, I guess I'm going to share a window if I can. And I'm going to share this guy. Can everybody see my screen?
Indeed, it's coming up. There it is.
Okay. So basically, I've just got the start of the routine. I've included the library and put in STM32 free RTOS for the library. And I'm getting an error. And I don't know if everybody can see at the bottom in yellow. So it's telling me that the wrapper was verified for new lib version 2.5.0. And that's for memory allocation. Malloc-family are unchanged. So I believe it has to do possibly with this Malloc family, but I don't know where to find what is missing on this, the new lib version 2.5.0.
Well, it's a warning. Have you is it not working? Is that why you're saying that's why bringing this up? Or you're just concerned about the warning?
I'm just concerned before I go any farther.
I haven't. I mean, I've used FreeRTOS a bit on the STM32. I have not seen this warning, I think. But again, I'm not terribly surprised. I mean, there's some version of some library that's not what it wants. I'm not sure, how to fix it, to be honest. I wouldn't be concerned about it unless you actually have a problem, right?
Okay, I just pasted the part of the warning I got in the chat.
Okay, hey, Pat, can you go back on your sharing again?
Absolutely.
And slide down on past that warning. Did it build?
It looks like it built.
Did it say successful?
Yes.
Okay, I think I agree with Chris. I think this is just telling you it's just a warning.
Yeah, I mean, the warning is telling you.
I agree too. Run with it. Go. Run with it.
Ship it. The warning is telling you, by the way, we've tested this with this version of this new lib library. Looks like you're using a different version. You're on your own. Yeah, I wouldn't know how to fix it. That would probably be a bit of digging. And so I wouldn't worry about it unless you have an actual problem.
Okay, and that's what I've done is I've gone through digging through everything I could find on there, and I haven't managed to find anything that was mentioned in the warning. So I went through looking for new lib. I went through looking for memory allocation dash family to see if I could find any of these libraries that are there as part of another package, and I haven't managed to find anything.
Oh, Chris,
new lib would be actually. New lib is used to generate the C library. So, for example, on my Linux system, that's a GCC lib.a. It's not called new lib.
Okay, well, there is a GCC in the a GCC and a bunch of libraries in there in the folder.
Yeah, newlib is the C runtime library. It provides things like printf and file IO, all those standard C library functions come from newlib, but it's where it is exactly. I'm not sure, but again, I wouldn't worry. The one thing I was gonna ask, so I remember there were two versions of FreeRTOS out there for the STM32, at least at one point. So I don't know if you came across two different versions when you were installing the library. It looks like you're using Platform IO. So I don't know. Did you get an option there as to which version of FreeRTOS to use?
I grabbed the STM32 Duino FreeRTOS.
Yeah, Chris is right. You might want to look and see if Platform IO has a version of RTOS itself. And then the second thing that I've been helped me a lot on things like that sometimes is if you just capture a part of the warning and do a Google search on that wording of partial, just like where it says warning, blah, 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 just put that up in the Google search, and often that'll lead you to somebody else talking about it.
Yeah, I've done that. I've did that quickly, but I get a whole pile of stuff, and you're into a whole bunch of reading. So I said, I know what I need to do. I'll talk to the guys tonight and see if they've run into this.
Yeah, but look at Platform IO packages, because I believe I think there is a FreeRTOS package specifically for Platform IO, if I'm not mistaken.
Well, it looks like that's what he's using, but what I'm saying is I think there are two flavors of it. Can you go back to your Platform IO screen, Pat?
Yep.
And show platform.io.ini? That should show what libraries it's pulling in, but just curious there. But when you probably use the Platform IO GUI, right, to find the library.
Yeah,
Is
I
that
did.
correct?
So
yeah,
I'm using the STM32 Arduino free RTOS library. But in libraries, and I go to installed.
If you just search for, you go to libraries registry, search for free RTOS, you might find more than one hit that applies to STM32, and I'd have to see which one I was using. I just recall there might have been two at one point, and I'm not sure if one is better than the other, but it's just something to be aware of. Okay, so there's the first one.
Yeah, so
That
there's the
one's Atmel specific, it seems. That doesn't apply.
Yeah.
Okay, so then this is the one you used, I guess. Okay, maybe this is the only one that's available through the platform IO kind of registry. In which case, I probably would have used the same one. Yeah, no, all of this is now just stuff that's referencing it. So I think there's only one exposed through this list here. So I think you should be good with the one you have.
So yeah,
And
so
I will say I did run into one. There was one issue I did run into on STM32 with FreeRTOS. Banging my head against the wall for quite some time. It was a while ago. I mean, a couple months ago. And the issue I ran into was that I was calling some of the standard time functions that come from the Arduino environment, like millis, right? How many milliseconds have elapsed, or micros? I think it was micros. Kind of how many microseconds have elapsed between 2 points in time. And I was calling those functions from within an interrupt handler. And the FreeRTOS implementation didn't handle. Well, I'm not sure if it was FreeRTOS necessarily was to blame here. Maybe I shouldn't say that. I think it was just the Arduino implementation for STM32 didn't handle that situation correctly. So I was timing pulses coming from an IR remote, and some microseconds mattered. But if you call this function at the wrong time, that's supposedly telling you how many microseconds have elapsed, it's giving you bogus information, and then nothing works, of course. So just again, if you run into weird issues, come back and let me know.
Yeah, so I'm just starting down the road with this. So it's part of it is doing a little bit of learning with Ross, but as I was developing it, I wanted to go a little farther and put in free RTOS as part of my motor handler.
I think it makes sense. It makes certain things just more easier to do. I mean, like I said, I've used it on a couple things. You have to use one? No, I mean, but it just, certain things become a little easier when you have a couple tasks. Just keeps things clean and neat.
I second that. I use a RTOS on all my robots, and it really does simplify a lot of things. It's not required, but it makes things a lot easier.
Yeah, well, that's what I'm looking for as part of the communication. It would make it quite a bit simpler to communicate at the right time and be able to sequence it.
And Pat, it's also the case that those warnings you can probably ignore. I mean, unless they just annoy you to not have a nice clean compile,
No, I just wanted to make sure I wasn't having an issue. Looking at it, it was just mentioning that, hey, maybe you got a problem, and being a warning with a memory allocation family, I was worried about, okay, well, hang on, I'm going to have a growing memory consumption, and it's going to crap out at some point.
I would tend to agree with David that as a software developer, if you have a choice between an error and a warning, if it's actually not going to kill anything, you put a warning in. But if it's actually going to have a downside effect and it's serious, then you make it into an error or an exception. And so you can ignore warnings generally.
Okay. Yeah. And when I look into the routine that's calling the error, it's basically just saying, hey, if the major revision isn't 2 and the minor major revision isn't 5, give this warning, and that's what it does.
And I think, I wouldn't worry about it until you actually see something actually break. If it's a warning and on a version number, yeah, I'd leave it. Don't worry about it anyway.
Now, one thing I was doing, and mainly, I guess, prompted by the fact that certain nuances weren't working right, and I was using FreeRTOS on a couple different boards. I was, playing around with Platform IO, taking advantage of the fact it makes so easy to install a library and run some code on an Arduino Mega or just a regular Arduino or whatever you have, right? So that was kind of the nice thing. So I did find it helpful to have a little bit of a sanity check code where I do things like, okay, go sleep for what I believe amounts to 1 second. And let's check if it's actually, about 1 second, or if I'm off by a order of magnitude, or if something's just not configured right with the clock or with the timers or, with the prescalers, and, so some sanity checks can be helpful, right? So you avoid, you banging your head against the wall, or even like you mentioned, memory allocation. I had one sanity check because on the smaller Arduinos, you quickly run when you use FreeRTOS on the smallest Arduino, you're basically out of memory, after 2 tasks. And so I had some sanity checks say just to confirm memory allocation works correctly. Okay, how much can I malloc? Okay, free it again, allocate again. Okay, it all works. Now continue. Just so again, a couple sanity checks to make sure between Arduino and FreeRTOS all put together, it all, is sound on a given board. Timers and memory allocation, things like that.
Matt, just as a FYI, the newlib library is basically a rewrite of the basic C library that's smaller and intended for embedded systems. And there's even some pieces of it you can set up to just be stubs. Say I'm on an embedded system, I don't have a file system, so I don't need FDisk and a bunch of other things. So it'll just set up stubs for you. But basically it's, the libc is pretty big, and it was supposed to be, when it was created, a reduced set specifically for embedded systems. And they should all be pretty much the same. I don't know what their minor conversion numbers are, but the APIs are going to be the same. It's going to have the same functions, and you're going to talk to them the same way. So.
Okay, well that's I think that's exactly what I'm going to do, is ignore the warning and just worry about the errors.
Okay, don't blame us.
David Anderson said.
Oh, that's funny.
Much, guys.
Good discussion. All right, thanks. All right, so next, if we have Murray ready, then he's good. Who would like to go after next? Then after next time, okay, then Chris. All right.
I'm actually going to decline this week. I've been trying to debug this thing, but I'd rather than hack my way through a demo or something like that. I'll just have to decline and say next week, because what I'm trying to do is I was going to show, just to give you an idea for next week, I was going to show that I can set the robot forward, moving it forward, and then if I hit a bumper, it turns into that. I'm trying to think what the right language is in this group. I have to be very careful. To avoid the ballistic behaviors, what I was doing was I was adding a macro, which is scheduling things into the future, that was sending events into the message bus in the robot's future that were just being mixed in with the regular events. And then, so what I was going to do is have the robot move forward, hit the bumper. It would then begin backing up, and I turned the backup to like 10 seconds. So if I then put my hand behind the robot, that would get interrupted by another message. So I could show the subsumption architecture happening. But I've introduced a bug, so I can't do it.
Demo effect happens.
Yeah.
Happens to so.
Well, no, I was just in the middle of things. I thought I'd have it ready, but no, it's not working. It was working about an hour ago, but
do
not
we get
now.
to take away one of his stars?
Oh, come on now.
An attempted star that I didn't get. So, oh well.
There's
time.
Stars just waiting to fall on you, Murray. So next week we'll have Starfall.
Yeah. Anyway, sorry.
All right. No, it's not, now we've got the anticipation, eager anticipation for next week. So you've set a stake in the ground. We'll be peer pressure holding you to it somehow. I think.
Well, I was gonna do it on the bench, but maybe next week I could do it on the floor. So that would be really, that would actually have the robot moving.
He's put the stake further out there. He's going
Yeah,
for big gold stars. All right.
Yeah. All right.
Cool. Mr. Chris, what you got?
All right. So, just for a quick visual reminder, all right, so here's my platform that I've showed a couple times. So this is going to be about the RAWs a little bit, all right? So I've been mentioned I was cleaning a bunch of stuff. I just had a bunch of random code and it needed a lot of cleanup. So I've been getting back into RAWs mainly because A, I found myself almost reinventing a few things that RAWs gives me, so I didn't want to do that. B, because Doug P's sort of use case and like what he just showed. I mean, to me, that's a perfect problem, where I feel RAWs can help you solve that in a neat way. Especially if you have a LiDAR or something that gives you similar type of data. So with that kind of use case in mind, right? So I've been getting back into RAWs to refresh my memory quite a bit. A lot to learn, a lot to forget. But so where I'm at right now is, I'm basically took the code that I already had to read my, my line sensor array, to read my BNO. Already had a bunch of code sitting around that was doing that and spitting out the data. Just refactored some of that, left that, alone as its own standalone Python module that I can use for whatever purposes, but then I created another, for each one of those, I created another Python module application that just takes that data and then makes it available to RAWs, in the way RAWs wants to do things in the data structures and the communication mechanisms and all the, publish, subscribe stuff. But, it turns out, again, once you know some of the basics, it's really not that hard. It's actually just a few lines of extra code in a way to go from what I have anyway, right? Again, without RAWs, I have to have code in place to interact with my PewDiePie, which gives me some of that information. But then to make that data available, publish it as RAWs topics, to use the RAWs lingo, is actually not that much code. So I have the line sensor array available as RAWs information right now. I have my heading for my BNO 85. I'm making that available to any other piece of software that wants it. Both the heading, also I'm just at the same time publishing my rate of turning because I need that. And of course the LiDAR is getting published. I didn't have to do anything for that. So that was already a standard kind of RAWs driver that does that. Wheel odometry, of course. I had some old RAWs code that was interacting with my Romy control board and then doing the odometry and making that available. So that's there. Both the calculated odometry, meaning X, Y, and theta, is getting published. I'm also actually publishing the raw encoder clicks, just in case I ever want to do something different with them. Again, right now I'm not using it. I'm just using the X, Y, and theta directly. But the raw encoder clicks are there if I ever wanted to just use those directly. Oh, yeah, and because I have the BNO, right, so I updated my odometry logic to, of course, use the heading that I get from my INU rather than wheel odometry heading. I'm just taking the heading that comes from the INU. Again, so now that's where now RAWs comes in and helps, right? Because I was in a situation just before that. I had all this Python code and I needed data from here. I needed it over there. I needed the data from the LiDAR, and I found myself going down a path I was trying to keep it simple. I mean, not like Murray or anything, but I was trying to keep it simple, right? And still, I ended up feeling, hey, I'm reinventing the wheel, and so okay, back on the RAWS bandwagon, because again, it's already so doing some of that legwork, right? That's one of the things it does for you. If you're in a Raspberry Pi type environment with different pieces of Python code that need information from here and there, RAWS will just take care of all the sharing of that information, and you don't have to really, do any of that legwork. So that's how it's very convenient, right, to get the heading coming out of the IMU, just subscribe to it, and magically it shows up, and I can use it for the odometry calculation. So I have that there, and then I already had some code there that was reading, the joystick signals coming in from my PlayStation controller. So again, I had to just add a little extra layer to that code so that it publishes now that information as a RAWS command. In the standard RAWS mechanism, there's particular ways to do that. Again, once you have some of this basics down, that's actually not a lot of work. So I have now some of my sensor infrastructure all plumbed up, right, in the RAWS way, and was then sort of starting to experiment again with some of the navigation features that are in RAWS and the SLAM techniques and packages that you can sort of use and that I've struggled with in the past. So I'm getting back into that. Now, one thing I was doing to tackle some of the problems I've had in the past with the fact that the LiDAR distorts, kind of the picture so much when you're moving your robot, or especially when it's turning, you get this distorted LiDAR scan that really throws off some of these algorithms. So I added one, again, that's where sort of RAWS, kind of makes life easy. What I've simply had to do is add, 20, 30 lines of Python code where I take in the readings from my LiDAR, take in the reading from the IMU. Hey, if I'm turning at a rate greater than 25 degrees a second, which is the number I'm using right now, just throw away the LiDAR data. It's no good. It's going to be all distorted. It's just going to confuse the heck out of the algorithm, and that, and so the point really is, again, all this plumbing that RAWS gives you suddenly makes some of those things relatively easy, right? So I take in original LiDAR data, spit out new LiDAR data, and I'll show that in a second visually. And the algorithm that consumes LiDAR data usually wants it on a certain channel or topic, but you can tell it, hey, go listen to the LiDAR data by some other name, right? Because I'm publishing new LiDAR data that's coming in at a slower rate because I'm throwing some of it out. And so again, some of this is all relatively straightforward. That's all sort of the plumbing that you get with RAWS. You can say, yeah, take, just pretend it's called this instead of that. And so I have that all sort of plumbed up together and was playing with the one of the several SLAM packages, and I'm just going to start showing that visually, where this particular one is SLAM, as in literally the simultaneous localization and mapping, which is not necessarily what you always need. You really just need the simultaneous aspect if you're dealing with an unknown environment or floor plan of some sort, right? I mean, a lot of times, frankly, I'll probably start exploring a little more just the localization part of it, because I know the floor plan of my house, right? Where I can create a map, save it, and then just use it. I mean, so it's you in the kind of things I'm usually interested in doing. I usually know what the floor plan looks like. Everything that doesn't line up with the floor plan, well, that's just an obstacle, right? It's not, doesn't need to be in the map. Not, if there's a laundry basket in the hallway, well, that's an obstacle. It doesn't need to be part of the map. So I don't need to necessarily create the map, while I'm sort of exploring the environment. But again, many of the algorithms sort of are packaged that way. And of course, the localization part is a bit more interesting, right? Because that's what helps you deal with the, inevitable drift of your odometry and even the IMU, right? Because over time, that is gonna sort of accumulate some error. And so with the localization, and let me start sort of sharing, that's kind of the main reason why I'm sort of looking at some of those SLAM packages from ROS, because to me that's one way. Okay, select the screen, screen or window, entire screen.
Chris, can I jump in here with a question?
Go ahead. Sorry if I'm going a bit fast. Yes, go ahead.
Back up. You were having problems with vibration with your LiDAR, and that seems to not be a problem anymore. How did you fix that?
I slowed it down.
You slowed it down.
I'm not pushing the LiDAR to the limits because on my lightweight platform, I just can't. And I don't want to figure out a solution to the mechanical side of it. That's just not me, right? So I decided not to let it be a distraction and just slow the LiDAR down to a 15 hertz scan rate. And at that level, the vibrations are not there. Once you get closer to 20, which gives you, a less distorted scan. So I have to give up a little bit of performance, but no distortion. So let me just see. I'm not sure how to on this Linux computer how to share just one of my two monitors. I'm a little stumped by what the option it's giving me here. It almost looks like when I hit the share button, it's gonna share both of my monitors. Let me see what. I'm not quite sure what it's sharing right now. Both monitors?
Both,
Yeah.
one above the other. Can you share a window instead?
Yeah, okay. I'll do window then. I'll do window. Fine. But I wanted to share. This is a bummer. I'm a little disappointed here by this Linux. Is it Firefox or Linux? I don't know. All right, so I have to do it this way. So my point was, okay, so I'll do one screenshot at a time, and then I'll show a live thing. But I just took a screenshot of the endpoint after driving around for 5 minutes. That's without any of the fancy SLAM stuff. That's just the LiDAR, is the yellow dots in my heavily cluttered office. And, wheel odometry, keeping track of things, and the IMU. And the red arrow represents the robot. The origin of the arrow is kind of the robot's center, okay? And I started driving around at, you see where you see the grid, right? And two grid lines meet. You can see my mouse cursor, right? No, wait, I'm in the wrong window. You can see my mouse cursor, right?
Yes.
So where these two grid lines meet, that's origin. That's 0, 0. Okay, so I started out here, facing in the same direction, driving around for 5 minutes, and you'll see that in a second. I was making a bunch of crazy turns, and then my odometry is not perfect, but it's not bad, right? After 5 minutes and a lot of turns and twists, it's physically back in the origin, but you can see that the odometry is telling me, okay, I'm like 20 centimeters north of origin, right? So that's without any of the localization going on. It's just purely odometry, and it is what it is, right? It could probably be calibrated slightly better. You can see I don't have much of a heading error thanks to my BNO 085, right? So just a little bit of, X, mainly an X, no, actually Y-axis, I guess, offset here. All right, so that's, as expected. Now, if I switch to my other screenshot, and I don't know if you can see that, the sharing, probably not, so I need to now, unfortunately, share. This is frustrating because I don't know why I can't share just my screen. That is rather annoying. So sorry about that. Let me share the second one just to make the point about where localization comes in. So, so this is now, again, after 5 minutes of driving around, and because I'm doing this with recorded data, and I'll talk about it in a second, it's processing the exact same data, but now it's combining the wheel odometry, IMU, and output from the SLAM module. And the map that it's generating, okay, it's interesting, but focus on where the robots is, right? It's right there again. It's right there at the intersection of the two grid lines, right? So again, that's what the localization is doing for me. It's it's compensating for all that odometry drift and eventual IMU drift. It's looking at the laser scan, right? That's where the laser comes in, and that's where the map comes in too, either a predetermined map or generated, on the go. With the laser scan matching, right? It kind of keeps trying to figure out, okay, well, odometry is telling me I'm here, but the laser scan's not quite matching up. So I think I'm really a little bit more over there, right? That's what's going on constantly in the background. And so after 5 minutes, right, it's right back there at 0, with pretty much a perfect heading,
Yeah.
right? So
Hey,
that's the localization in action. Yes.
Chris, is this just the Kalman filter in action? I mean, that's what I would expect with a Kalman filter.
Well, for sure, there are common filters going on somewhere. Again,
Yeah.
to me, it's honestly just a black box, right? That's,
Yeah.
Once you get into these bigger ROS modules, I don't know what's inside it. I just know what it does, right? I don't know how it does it, to be honest.
Are you using one or two? ROS 1 or ROS 2?
This is ROS 1.
Okay.
This is G mapping. So more specifically, I'm using G mapping or grid mapping, which is one of the many SLAM implementations that are readily available on the RAWs. You just turn it on and you set things up so it gets the data at once, and it spits out some data. In this case, it spits out a map, and it spits out a new pose for the robot. That's what it believes the correct pose to be, right? Again, now grid mapping is interesting because it takes into account odometry, right? So it uses odometry, to help with the alignment of the laser scan against the map, right? So that it doesn't completely lose track of things and supposedly use less processing power, but I haven't necessarily seen that. But, again, the point here really is, okay, no matter how much I'm going to drive around here, it's not going to sort of lose track of where it's at, right? Because it's using odometry, IMU, and the laser and how it's lining up with the map to help itself localize.
Yeah.
Okay, and it's doing a pretty decent job. Okay, so now how I got there, let me just briefly illustrate sort of what that looks like, how it gets there. So I have to stop sharing again, I guess. Stop presenting, and then I'll do a new window. Got to figure out how to do the whole screen. This is okay. So now I'm going to do this tool, which again is one of those things that RAWS gives you, even if you don't want to get into any of the SLAM, and I'm, not sure if my brain can handle it. There's just too many things to learn and to know. But my point of this is some of the tools and infrastructure that RAWS gives you, right? There's value in that, even if you don't want to tap into some of the more, advanced and sophisticated turnkey packages, right? So with the tool like this that visualizes the data really well, so let me just fire off a few things in the background, and you can't see because my screen's not shared. But what I'm doing now is I'm going to play back the data that I recorded, and that's yet another of these nifty things that ROS just gives you that you don't have to build yourself, right? And what I mean by playing back the data, so I was running my robot around my office and down the hall and recording everything, every single data point, Odometry at 100 hertz, IMU at 100 hertz, the laser scan at 15 hertz, what else? Battery information. I mean, whatever I'm generating, all these pieces of information at rates up to 100 hertz, it's all going into a log file. It's all time-stamped, okay? So now what I can do, because some of these more advanced algorithms have 24 parameters that you can tune, and that's part of the problem, unfortunately. Right now you can take this recorded data, play it back, and see what the algorithm does. Like, how well does it localize? Does it get confused when the robot's turning too much? Then you can tweak some parameters and run the exact same data through the algorithm again. Okay, so it saves a lot of time and makes things very repeatable. So let me just kick this off. And you can't see if I, wait, where am I? So I'm going to kick that off, and then I'm going to kick at the same time, okay. So I kicked just off in a different window the playback of the recorded data, and I kicked off the mapping/localization program called Gmapping, and another program was already running that's filtering out the distorted laser scans, and we'll see that in action in a second. But so what's going on now, right? So again, I just want to demonstrate the visualization that I find really helpful, again, especially when you're dealing with things like LiDAR, is you can see what the robot sees, right? In a way that's intuitive, and I think that's a real helpful thing. So let me just hit the continue button there. So let it continue putting out the data. So in a second, it's going to start driving. And I'm going to turn on the yellow dots that you see here. That's actually my filtered laser scans. Again, not something fancy going on here. You'll see occasionally, you'll see the laser is not updating. Let's see, wait for it. And that's, when I turn, okay, just now I was turning, and maybe you noticed it, maybe you didn't, but you might have noticed that the yellow dots weren't flickering. The laser wasn't updating, and that's because I deliberately threw it all out, right? Because I didn't want the algorithm to get confused, which it often does, and you can see still, you can see a little bit, the yellow is not always perfectly aligned with the black, again, and that's all, because of the rotation of the robot. I'm not filtering out everything when I'm rotating, but it's not getting confused. It's eventually snapping back. The yellow lines will snap back to the black lines. Again, that's kind of the localization in action. The other thing that you might or might not see, and it's difficult to see, but if the red arrow, right, representing the pose of the robot within the map, will occasionally jump a little bit. And that's because, again, it's occasionally realizing, oh, wait a minute, I thought I was over here, but now with this new laser scan coming in, I think I'm actually a little bit more over here, So it could easily jump around a little bit. It's not the real odometry acting up or anything. It's just the localization saying, yeah, you know what? I think I'm actually over there, right? So again, it's probably not obvious because I don't know at what frame rate this comes through. But now let me add to this. Sorry, where am I clicking? Let me add the original laser scan data, and I don't know if this is going to be very obvious. So when it turns, now watch for it turning. You see how the white laser dots were kind of completely, totally unaligned with the map? Did that, I don't know if that came through at all. You saw the little white dots? Okay, so that's the stuff that I'm filtering out, right? Because when the robot's turning and the laser is turning, it's just you get a completely distorted scan. If I were to feed that original laser data directly into this algorithm, it usually gets confused. You know, it would not be building this reasonably decent looking map. It would just get utterly confused, and that's why, you know, I end up throwing quite a bit of this laser data out. Okay, now this is just the white one. This is just the original data, as you know, as produced by the LiDAR. But I throw much of it out and just keep the ones that get produced when the robot's not turning. And you know, it turns out for some of these algorithms, the update rate of the LiDAR is not what really matters the most, right? So I can crank it up to 20 hertz, right? I do 15 right now. It's perfect. 5 hertz update rate is perfectly fine, but it's the exposure time, you know, as you may, right, is what matters, right? If it takes too long for one scan to complete, that's when you get completely, you know, distorted data. So I'm gonna run the LiDAR as high as I can afford to before it vibrates, but doesn't mean I need to process the LiDAR data at 15 hertz, right? Some of these algorithms get quickly overwhelmed. I mean, even this application here that's visualizing everything, at some point it's going to get overwhelmed if you ask it to visualize this LiDAR data at 20 hertz coming in over the network. So, but again, you know, some of these algorithms, they don't really mind if the LiDAR data is coming in only at 5 hertz, as long as it's not distorted, right? So I was playing with that and trying to find the balance here between update rate of the LiDAR and you know, how much I can throw out. And you know, so that's, you know, I'm at a point where I have at least this particular G mapping algorithm working. I wanted to try some of the other packages that are out there. Google has one, Cartographer. There's several others that, at least 3 main ones that I wanted to compare and see which one, you know, kind of works best for my type of use cases, and then go from there. But again, mainly trying to leverage the localization part of it more than the mapping part. And there's other algorithms that do only the localization, where they expect you to give it a map, and it'll try to localize itself, you know, within that map. So I have to, you know, try those out again, which I've done a couple of years ago with not too much luck, but giving it another go. And yeah, so far I'm happy with the results. Obviously, this is not doing anything useful yet, right? So now this is all just building blocks. The idea is to put now some logic on top of this, right, to do what Doug just demonstrated, right? So this isn't doing anything at all. It's me just driving around remote controlled. But again, the idea is to use these data structures that ROS gives you, the map, you know, in the way it represents all this information, and then build your logic, you know, on top of that. So that I haven't attempted yet. That'd be obviously one of the next things to figure out how to do.
Cool.
I do note with almost no irony, though, that there was a small bit of criticism about the complexity of what I was doing, and this seems like enormously complex.
It is, unfortunately, and again, that's why I have jumped off the ROS bandwagon at one point, and because it is a lot to sort of keep track of, but again, some of the, you know, again, well, once you get into the navigation side of it and the SLAM side of it, yes, it does get complex because now suddenly there's a lot more concepts that you have to understand how is ROS doing things. But even if you leave that aside, like I said earlier, now if you just wanted to tackle some standard use cases in a simpler fashion, I think because of tools like this that visualizes the data so well, and because of some of the underlying plumbing that it gives you that you created again from scratch, right? I feel it, I feel you did end up recreating a lot of the things that ROS gives you out of the box. And yes, there is complexity there. Everybody who has used ROS has admitted to that. But once you get to some of the use cases that just a little bit more challenging, like what Doug was showing, that's where some of this complexity I think starts to pay off. Once you can learn to manage it a little bit, right?
Yeah, I don't think anybody would discount the value or the amount, the features that are available in ROS. But I'm on the ExoMy Discord server, and looking at even like Kumar in this group, a lot of people, they sort of hit that wall and just even installing ROS. And I've kind of played with it for about a week or so and just kind of went, okay, too much for me right now. And like I said, it's a huge package and it has enormous features and lots of value. And the only thing I can say to defend my approach is that I'm not even trying to do anything like that. I'm actually doing something entirely different. But the ExoMy that's its OS is ROS, and a lot of the people getting into that project, the first thing they run into is once they've got the hardware built and the 3D printed, robot sitting in front of them, they go to install ROS, and that's quite a challenge.
Yeah, actually, they're told to install the Docker container so they don't have to really install ROS itself. But then you have the whole Docker infrastructure and all that kind of stuff baked in. How does that all work? And where's this picking these things up? If you want to add something to it, how do you map the module into the thing? And the killer on that is you think you're doing a good job, and you're adding stuff into the Docker container, and things are going and doing, and then you got to turn it off. Sometimes you got to go to bed. Sometimes you got to reboot something, whatever. And what's happened is because the way that Docker container is spun up, it starts from fresh again. So all that work you did just went away, and you weren't aware that you're going away, and that's a bit frustrating. And you got to dig into how Docker's fired up and how do you mount volumes and a lot of those kind of things. And if you're not even aware to look for that kind of stuff, I don't even know how to tell you. You're just going to hit that thing and you're just going to be mad. If you just fire up the ExoMy and just drive it around just the way it is, it goes pretty easy. But it's when you go changing things, it gets you got to understand a lot more than just fire up that container and tell it to go. It takes a bit.
Yeah, I mean, go ahead.
No, I was just going on about that.
No, I think I heard my own echo, so I thought someone else was talking. But yeah, so Docker, I avoided that. I'm just running Ubuntu right now on my Raspberry Pi, just to take a whole layer of complexity out, like the whole Docker thing. Not an expert on it. Just take it out. Just use Ubuntu. Install it all. Done.
Those ROS guys really like Ubuntu. So if you run Ubuntu, guess what? Their walkthrough steps and stuff, like Chris will tell you, probably just works.
It just works. Yeah. So there's ways to make it more complicated than necessary, for sure.
Yeah.
Right. And if you're not an expert in all of these things at the same time, life gets hard. But so there's easy paths to take, and that would be to just start with Ubuntu, install it, and start out with some of the simple features that it has. If you're starting cold and then trying to get straight into the navigation stuff, you're just going to get lost in all the concepts. I'm still trying to wrap my arms around, more about one of the most fundamental and probably most useful concepts in ROS, and that's how it sort of works with coordinates and coordinate frames, right? Because it keeps it keeps track of, okay, this is your robot base and the center is here. Okay, you have a laser mounted on it. Where is that mounted relative to the robot base, right? Then the laser produces readings, right? 1 meter in the distance. he keeps track of the fact. It knows that, okay, the laser says, I see something 1 meter out. But because it knows where the laser is relative to the center of the robot, it now knows where that obstacle is relative to the center of the robot, right? You know what I mean? So it has this whole coordinate frame and coordinate transformation scheme going on that, is, on one hand, it's not rocket science, but it's just one of these concepts that you need to get your arms around before you can sort of do things. And I can't say I fully have my arms around it yet. But it's one of those things that are very powerful, because now suddenly, again, especially when you're dealing with sensor information, like my IR and ultrasonic sensors, I don't have those yet incorporated. That would be one of the other things that I'll do at some point. But my IR sensor is pointing, at some angle away from the robot, and you can just tell ROS what that angle is, right? Because then suddenly whatever reading you get from that IR sensor would show up on that map that I just showed magically in the right place. You know what I mean? It's doing all this coordinate transformation for you in the background once things are set up correctly. And that's where it's certainly a little complicated. Again, once you get into the navigation and the mapping side of things, those whole coordinate frames, they can trip you up quickly and easily. But it's when you want these sophisticated use cases like Doug showed, I believe that's where ROS is going to shine, if and when I master it.
Yeah, they got some, I forget what they call it, NUO something coordinate system, where they have it as a local space, so it's local around you, and they've got a way to translate into global coordinates for outside. And I was trying to do that, and I just couldn't get a whole bunch of other stuff working, so I didn't even get to try to see how hard that was.
Harold,
But they have a really nice coordinate system and a really nice way to track stuff, and there's lots of smart people that've done a lot of work, and I just want to use it.
Yeah, that's the promise of ROS, is that you can stand on the shoulders of giants.
Yeah.
That's the promise. The problem is if you don't understand any of it and it doesn't work.
It's a hard climb. It's a hard climb. There's no doubt about it. Yeah.
Yeah. But I do think that it looks to me like Chris is getting, you're getting what. I mean, I don't know. I would say you chunked a really hard part by getting ROS working with your LiDAR. I'm sure there's simpler sensors and stuff, communication.
Everything I showed so far, that was easy. Trust me, that was relatively easy. Now making use of the information now, it's again, none of this is any actual robot running around autonomously yet, right? So the next steps are the harder ones. Everything I've showed so far is just a matter of setting things up correctly, okay, with a little bit of manipulation of data so that I keep the algorithm happy and not confused. So that was my only value added. The rest is just putting the pieces together, which of course requires a bit of understanding of ROS, otherwise you're not putting the pieces together correctly.
Carl, I can actually do a demo. I have fixed the bug.
You have? Well, that's fantastic. Excellent.
It's only going to run on the bench. It's not on the floor.
Well, that's still something. So Chris, that's I don't know if it's physical, but that's a pretty good demo. I'd say it's at least silver or bronze star worthy.
Thank you.
That's still a pretty substantial chunk of some kind of demo there.
Thank you.
You had things twiddling around on the screen. That's not easy.
Gonna go for gold next time.
There you go. We'll look forward to it. Well, cool. Well, then, having said that, thank you. And then, so Murray, let's see.
Okay, I've got kind of two sides of this. One is I can show you the screenshot of the actual messages coming from the OS, and the other is I can show you the robot. So I'll show you the robot first, and then I'll run it again, because I can't do a split screen, unfortunately. So this is the robot. We'll see if I can. Oh, I got to turn off my what is that? The blurry background. I learned that one before. Change. How do you Oh boy, settings, right? Otherwise, you guys can't see it. No, it's not it either. How do you change the background?
It's down in the bottom.
Change the layout, I think, isn't it? No. I can't find background. Otherwise, it's blurry.
Apply
Whiteboard.
visual effects.
Pardon? Oh, apply visual effects. Aha, yes. Because otherwise, it's going to be blurry. There's no point. Okay, here we go. Turn off that. Ah, there. Okay. Now, I will just aim at the robot. There. So everybody can see that.
Yippers.
Get everything out of the way. Okay, so that's okay. Now, I will start the thing up. Okay, the OS is now running. It takes a little bit. There it goes. Okay, now I'm going to hit a key to start the thing forward. So, it's it's reacting to being in front of my desk. It's backing up because it was seeing something behind it. I'll try that again.
Murray, your wheels are exactly covered up by your Robots New Zealand label, so we can't quite see the wheels.
Oh, okay. Tell you what, I'll lower this even further. How's that?
That's better.
Okay. It was actually, I had it aiming at this and it was actually backing up. It was not going to back up because it saw something behind it. So here we go. So now you can kind of see the screen actually. There's a split screen.
Yeah.
So, okay. So now it's just sitting idle and I'll just hit a key to start it up and it'll start running forward. Now, if I hit the bumper, what it'll do now is it'll stop and schedule. Oh, it did actually already see me. There. I've moved it, so it's actually got all sorts of stuff it's sensing now. Try it one more time. I think it's sensing stuff. That's the problem. Because I've got infrareds in the back, and so here we go. Try that now. It's going forward. I'll hit the bumper. It'll then back up. And then I'll put my hand back here, and that stopped it. So that was the demo, actually. So what that was showing was that if I hit a bumper, it'll schedule something into the future. It begins doing its scheduled macro, what I'm calling a macro, which is beginning to send messages into the message bus as time goes on. And then I interrupted that with a higher priority backup so it wouldn't run into something from behind. Now I'll try to show you that with a shared screen. So share your screen. I never can find this. Where is that? I think some of us use this more than others. I don't use this often enough to remember where everything is. Let's see. Present now. A window. And this is where on this Macintosh, for some reason, it doesn't show the window. Okay. Oh, there it is. Okay, good. Ah, that was interesting. It popped up for a moment and then went away. There. Oh, got it. No, it won't capture it. It's funny. I'm clicking on it. It shows there. No. It shows up for about a second, and just as I click on it, it disappears.
I just want to interject that all of this stuff seems to work really good on Windows and not on non-Windows computers. Just saying.
You mean the video conferencing stuff?
Let me point out that it works fine on my Linux system.
I'm running Linux as well, and it's working absolutely fine. I'm
actually on a Mac. This is actually a Mac that I'm on, by the way, not this.
So why do you guys got to be hating on Murray, saying your stuff works fine when his is not? Come on, give him a break, you know?
I'm normally Firefox and Google Meet.
How about screen instead of window?
I give up. I can.
Murray, what about share screen instead of window?
What's that?
Maybe share screen instead of window.
That's an idea. Yeah, because I can't get it to. As soon as I try to capture the window, it disappears on me. So
we've seen that before. Just share the whole screen.
Oh, it's a Heisen window.
Yeah, exactly. So here we go. Your entire screen. So you won't be able to see the robot this time. Okay, share. Okay, here we go. Now it's working. Let me know when you can see my screen.
Oh, it's coming up. There you go.
Okay, now
Green
I will
screen
flip
works.
over. Okay, now can you see my OS
Yep.
terminal? Okay, so if I start running cross minus S, so start, there it goes. Okay, now it's running, it's stable. I'm now going to hit a number 7, and that will start the publishing loop and tell it to move the robot forward. Oh, I've got 2 versions of it running. Sorry. I've got the one on my Linux. It's actually got 2 OSs running at the same time from different SSH sessions. The robot is confused. Okay, I'll try that again. There we go. I had the one from my Linux box also running the robot, and I don't have a PID or anything like that telling it that. Okay, now it's running. So now I'll say go forward. I'm not sure if you can hear that.
Yeah.
The robot is now moving forward. Now, if I hit the bumper, you can watch what happens. So now it's scheduling.
Yeah.
And that's it, done. So that basically little done at the bottom just finished that macro. And so what's happening basically is I've managed to get around having ballistic behaviors. That these behaviors that now get scheduled, stop presenting, I think, is that right?
Yep.
There, okay. What I've been trying to do is avoid ballistic behaviors. And what this is doing is scheduling using what I'm calling a macro, some events into the robot's future that are just mixed in with the regular events, but can be canceled by a higher priority event. So if something higher priority like the back bumper comes through, it will cancel any macros that are running and take over the robot. And so in a way, I've kind of just, it took an extra week or so because I was having lots of timing problems which I won't get into too much, but it has to do with the fact that I was using this, the clock signal, which is used by the PID controller and just about everything, and it wasn't returning fast enough. So every time I started to use the macro, it would overload the clock, and then the callback wasn't coming back every 20 hertz. It was now slowing the clock down. And so the PID controller went apeshit and was just flying all over the place. But I fixed that, so it actually now works. So I'm pretty happy with that, and I think that hopefully I can maybe do like a on the deck demo of this actually running. So I could run the robot towards a wall or something like that, and it would then back up, and then I could put something behind the robot. And if that higher priority backup, because there's nothing behind there, there's no bumpers behind the robot. So if it sees something while backing up, that's the highest priority. And in fact, I've got on the robot, I've got this mast sensor right here. And if that mass sensor senses anything, it actually shuts the whole thing down. I mean, it just stops everything because obviously I don't want to have that run into anything and damage the robot. But
hey, Murray?
Yep.
Yeah, maybe I'm missing something because I just had a computer crash. But did your backup sensors should only read them when you're going backwards.
Right. That's
Okay.
Yeah. They're actually they're very, very high priority, and they are only paid attention to while backing up. Yes.
Okay, all right. Because if you see something behind you and you're just sitting there on your stand, it shouldn't make any difference unless the wheels are turning backwards.
Or a torpedo is approaching rapidly.
Yeah, or a cat.
Yeah.
That's another avoidance behavior then. Somebody running into you from the back.
Yeah.
Well, I've got a kill switch and I've got this mast sensor, and they're actually the same thing. So if either I hit the kill switch or the mast sensor, it just stops the robot dead in its track and turns off the OS. Because at that point, I don't want to be running this thing. I don't want for example, the mast to run into the sofa or something like that and just snap it off. So it's about a higher priority as anything I can think of is that mast sensor.
Is your scheduling something into the future sort of the equivalent of Doug setting a temporary waypoint?
Well, the thing is that I've got a directory called macro, and I can put any number of Python scripts into it that have names, and then you can refer to them by name. And so I can run a macro for any reason if I want. And this happens to be an avoid macro, and the macros, as they run, schedule into the future, basically. So the macros are effectively just a timer that's running on the macro itself. And so the macro is, as it runs, running concurrently with the OS of the robot at that point. So the robot's still running, but concurrent to that is this macro that's now running sort of parallel to the robot OS. And as it's sending messages or doing whatever it's doing until it finishes, let's say the macro lasts for 15 seconds, it's just potentially sending messages into the robot's message bus during the time that it's running. And then it stops. So, and a macro is just a Python file. It can do anything. So,
Query, isn't that just a ballistic behavior?
not really, because you can.
Well, let me go on.
Okay.
Let's be sure we have a clear definition here.
Yep.
A servo behavior is one which only runs while the signal is present.
Mm-hmm.
Ballistic behavior is a behavior that continues to run after whatever signal triggered it has gone away.
Mm-hmm.
So it's
Right.
something that continues to run in time after it's been initiated, even though the signal that initiated it is gone. So that's what you're doing, right?
Okay, but
So
the
what you're
way we
doing-
talked about this was that a ballistic is a bullet that's been fired that you can't pull back into the gun. It's fired.
Nobody ever said it's uninterruptible.
That's an odd definition. I prefer my simpler definition that I just gave. Servo behaviors run as long as their input is active. So for example, the sonar turns you away from an object as long as it sees the object.
Right.
A ballistic behavior continues to run after it's been triggered. So a simple example of that is a bumper press. The bumper press is long over before the ballistic behavior ends. It just seems like that's what you've done here, and you're just calling it something else.
Okay, I won't. According to your definition, the one you just gave, I am doing a ballistic behavior. Yes, but and you and Kareem are right that there's nothing different from that definition. I am simply triggering something that now runs into the future. But it is the only difference that I can see is that while it's running, it's simply intermixing its signals into the robot's existing sensor signals, and at any time, any one of those other signals can override or cancel the continued running of the macro. So I'm not sure if it's hugely different, but it to me seems that, like I said, you can cancel the entire. Let's say it's a 15-second behavior, and 5 seconds in, something happens that's a higher priority. That priority behavior can actually cancel the continued movement of that ballistic behavior, or it can just leave it running and let the signals intermix.
I understand what you're saying. I think you're focusing on the ballistic terms in terms of whether or not it can be interrupted, and that's an auxiliary concern. The thing that makes it ballistic is the fact that it continues after the input that began it is gone.
So
okay, and I don't disagree with that. What I was trying to avoid doing was what I was doing previously, which was when I had my bumper behavior, it would trigger and then begin backing up for 3 seconds or whatever, then turn left and then stop. And during the time that was running, it wasn't interruptible. And this now, I've got a way of writing behaviors of any kind that can now run concurrently with the robot's OS and intermix signals if I want them to.
I see. Typically what happens is it's not that you can't interrupt a ballistic behavior, it's that basically that screws up the behavior. That is, if you're going to draw an A on a chalkboard and you're interrupted halfway through that, you can't pick up where you left off. So basically the only way that you can interrupt a ballistic behavior is to abort it, which is, I think, what you're describing.
And I think that we would both agree that we don't generally want ballistic behaviors, and the only time that I see that I even need to use them is in avoidance. So like when I bump into something.
Well, they have their uses, but I think if you're looking for a subsumption paradigm, which I'm not sure anybody here this evening is, they're to be avoided.
So, David, can I test my understanding of the way your simple definition of servo? And you said that I think I heard you say that a bumper it's more ballistic than a servo. But it seems to me that if I had my bumper wired so that when the bumper is not compressed, wheels would turn forward, and if the bumper was compressed, the wheels would turn backward. It seems to me that
I don't think that would work because
well,
the bumper uncompresses the instant that you.
Or does it? I think that might depend on the style of your bumper. If your bumper has, like, let's say your bumper
You're
has
going to have a bumper that gets compressed and stays compressed even when it's no longer touching anything.
no. Well, I'm saying a bumper. Let's say a bumper has some compliance, so that, you know, if this is the bumper, then let's say it hits a wall, and it like closes a switch, and the bumper keeps compressing. Well, at some point it closes a switch, the wheels start to back up, and it keeps backing up and it keeps backing up. So it seems to me that in that world, by the definition I heard you say, that would be considered a servo, because the wheel direction is constantly controlled by whether the bumper switch is closed or open.
I think that's a pretty artificial. I mean, from what you described to me, what I would see is a robot that would pull up against a wall and go.
Yeah, right.
Is that the behavior you want?
It would compress. It might be. I mean, maybe the bumper is kind of metal and you want to work it and do some
But
work
that's not
hardening
what
on
you
it.
did. What you did was you said
Only if it's got spikes.
you said you run into the corner of the building and you've compressed it.
Yeah,
That's what you said. And you
That's
said
right.
now you're backing up and it's uncompressed, but then you continued backing up long after it was uncompressed.
well,
So that's
Okay.
a ballistic behavior.
that's a terrible. It could have
But
transitioned to another behavior.
Carl, let's be realistic here. That what you want to do is back up for like 3 or 4 seconds away from the wall, and during that 3 or 4 seconds, that behavior is ballistic. I think that's
Or-
what David.
Or as a servo jackhammer. Okay, I'm going to stop being obstinate now. I just wanted to test my.
Well, this is really a term that Joseph Jones and his group came up with. And if you go and read his books, he gives a nice long definition of servo and ballistic that basically matches what I just said.
Yeah. Okay.
And the idea being that ballistic behaviors are initiated, but whatever initiate them is long gone before they're done. And so they have to continue on timers, which is what Murray was describing. Maybe not timers, maybe a certain number of encoder ticks to back up a certain distance or whatever. But at any rate, whatever initiated them, that's gone long before they complete. Whereas a servo behavior is like you drive toward the wall, the IR sees the wall, and you turn away from the wall as long as the IR sees the wall. Doug, in his presentation today, I asked him if he had side-looking IRs. So as soon as he's clear of the obstacle, he could turn back toward the waypoint. He's not doing that. He's doing basically a timer. You turn to avoid the obstacle and draw it for a certain period of time and then look back and see if it's still there. So that would be a ballistic behavior. Basically what he's doing is dead reckoning. He's doing navigation by dead reckoning, which would be a ballistic behavior. When he gets an obstacle in the way, that's really not a servo behavior because he doesn't turn until the obstacle is gone.
Right.
He turns for a specific number of degrees and a
Yeah.
specific period of time.
Or some other hard fixed arbitrary.
Yeah, he's navigating by ballistic behaviors.
And that's actually, David, what I was trying to avoid was that, and it's not a matter of criticism of that or anything. It's more that was my first implementation, was that when I had a bumper press, I would back up for a certain amount of time. And even if it was interruptible, it was sort of like it would do this fixed, like you hit a cassette player and it just does this thing. And I was trying to avoid that. And so what I've got now actually intermixes signals into the regular operation of the robot, which I think is, I agree, according to that definition, is still ballistic, but I think it's a major improvement in that it can be interrupted and the behavior might not draw an A anymore, but at least it's pulling away from the wall until something says don't do that. And we can get all tied into definitions and stuff like that. And I whether I have a classic subsumption architecture or not, I don't know. It's certainly different than running an RTOS the way you are in C. I'm running an asynchronous message bus and all that blah, blah, blah. But I'm effectively trying to do what I think of as in the spirit of his subsumption architecture of the actual Brooks one with inhibition and all that. It's obviously changed a bit because it's a hugely different technology than he's using, but in the abstract sense, I think it's fairly close.
Ones and zeros are all the same.
Yeah, exactly.
In the abstract sense, the highest level is always ballistic. You turn on your robot.
Yeah.
Then the signal's gone.
Yeah.
It's all analog under the covers, or quantum, I
Yep.
guess. Okay.
Anyway, that was as much
Cool.
as I've got. The only other things I've got to report on is that I've got 2 Raspberry Pis came in the mail. This one is going to go on my Mars rover. And so I'm very pleased about that's a cool effect. Wow, look at that. Woo! Anyway, this is over, and I am actually starting trying to think who a couple people are trying to help me get into, is it Open EVA or whatever, the company that Chinese company that does PC boards. They have software you download and you can design your own PC boards and then send them off, and they'll even populate the boards for you. So I'm trying to build for my first PC board a power distribution board, which will basically house a whole bunch of the Pololu power regulators. So I'm getting the 15 amp 5-volt power regulator and then a row of sockets to put the other ones in, so I can put any number of well, not any number, I'll probably have 6 or something like that, but I can basically modularize the Pololu regulators, so I can have 1 6-volt and 3 or 4 5-volts or whatever, and just plug the regulators into this board, and then have the one big 15 amp one as the main power. But I'm in the process of learning how to design my own PC board, so that's quite a challenge for someone who did it with dots and ink back in the 80s. So
nice.
Dry transfer letters.
Yes.
Yeah, I've got a desire to do the same thing, Murray. And yes, I had dots and inks and all that kind of stuff as well. And I just, I haven't succumbed to that desire, even though I really want to do it, because I don't have anything useful enough to want to spend that time on it.
Well, you guys should remember that we have people in the group who do this professionally all day long and who are real good at it and who can knock out what would be a project for us that would take weeks in a morning.
I have not forgotten that. I just haven't found anything that I want to immortalize in a board, in a custom board yet.
Well, I just looked it up to make sure. It's actually called Easy EDA, and you download it, install it. It's cross-platform, and it has a schematic part and a board part, and you can populate the board with what are they called? Not templates, but
Footprints.
So you put footprints on your board, populate with the parts you want, and you send it off to this company, and they just make the boards for you. And it's pretty cool, and it's not even that expensive. And I'm not going to probably have any parts on my board, since I'm just going to have it populated with Pololu parts that I'm going to put on myself. But nice little foray. It'll take time though, and that's the thing. It's like, I could just solder these things together myself the way I have on previous robots, but I kind of want to have a MOSFET controller, so I can have a small little tiny switch to turn on the major power and just kind of do it right and have a nice power distribution board.
So a quick interjection, because you mentioned Pololu twice. I'm not getting paid for this advertisement, but they're having a sale until October 22nd.
Oh, I took advantage of that. Yes, that's when I bought all my power regulators. I got
cool.
10 or 15% off on them. Yeah.
Yeah.
Oh, cool. David?
Speaking of Pololu, brings to mind Adafruit, which in an odd turn of events, one of my colleagues at work has a project, a field project he asked if I would help him with. And the two pieces of hardware that he gave me, or that I have, he gave me this
Feather. A feather.
Feather Ada logger, and this a B&O 555. So, and asked me if I could connect these together and set it up to log data for him. Has anybody ever played with one of these? This little feather data logger thing?
Which feather is it? Feather is only a form factor. Which actual is it? ESP32 or which one?
It's an ARM chip. It says it's just says ADA logger, and I've got a spec sheet on it, and it's got a place to put a little
SD card.
SD card there.
It's probably a SAMD 51 or something like that.
USB. It uses one of these weird autofocus. But yeah, how fortuitous is that?
I'm going to bet a whole bunch of money that if you jump on Adafruit's site and put that in there and put data logger in there, there's a whole tutorial and it's probably somebody's already done it.
All right, I'll go look.
Yeah, I'd have to say that Harold's correct, that Adafruit's excellent. They've got a whole section of their website just on how to use every one of their boards with like pinouts.
Yeah,
downloads, the whole deal.
At the very least, what they're going to have on that is they're going to have a data logger, and they're going to have like a DHT 22 or 11 or 22, one of those thermistor, thermometer based kind of things. But anyway, it should give you the idea how all that stuff works.
It's probably there's a couple different ones, David. Looks like it might be the Feather M0 ADA logger, or the.
I think that's what it is.
There's actually about 3 or 4 of them though, different models.
Also noticed that the VNO 555 has the data and clock signals. It's got power and ground, and it's got a reset signal. Any of you who've used this, do you use that reset signal?
You don't need it.
I don't think you're going to need it. I think it's to recalibrate itself when you're doing the thing.
Okay, there's a VN, and then there's also 3.3 volts. Is that an output?
The VN is your voltage. Yeah, it actually has an onboard 3.3 volt regulator. That's an output. But honestly, if you either to me directly or in the mailing list, tell us which model it is, there will be a pinout on the Adafruit site for that particular model.
Yeah, Adafruit's really good since they use a bunch of 5-volt boards, and there's a bunch of 3v3 out there that on that board, if they can throw a regulator on the thing to give you 3v3 to help you out, they're really good about doing that stuff.
Because he also supplied me with this, which is evidently the battery that's supposed to power this whole thing.
Oh. Yeah. Oh, I think it might be the Adafruit Feather 32U4 ADA logger. It looks like the one. Actually, they're all kind of the same, David. They have the same form factor, and they look very similar. So, does it say on the back what it is?
Oh, we can't read that.
Down.
It says Feather ADA logger. Let me see what else.
It should say Feather 32U4 right next to the word feather. It'll have the actual chip on there right next to the word feather.
No, I don't see that there. It says M0 and 48 hertz, 48 megahertz, if that helps.
The M0 is one of the models. So that's product ID 2796, by the way. Yeah, that's the one. It's if you go to their website and search on it, it's
I'm there.
ID 2796, and they've got a tutorial.
Cool.
So is that the SAMD 21?
I put a link in the chat.
Are you going to do it, Carl?
I put a link in the chat.
Oh, cool.
Are you just supposed to be logging the IMU?
Yes.
Pretty straightforward.
I told him I'd look at it. I didn't want to get too cocky, you know.
Well, you've done a good job of looking at it. You even got us to look at it. That's good.
And certainly we're all experts.
Yes.
Cool. All right, well, Murray, I think that's at least a silver star for wheels turning and things. So
now, does it count if the wheels just turn?
I don't have. How many of us have wheels to turn tonight?
Good point. Good point.
Okay,
I'm okay with a silver star. Actually, I'll work for gold on. I think gold is on the floor moving. I have to agree with David. I think we should have a high bar. You have to actually have I have it on the bench moving. I could have it on the floor, but then it would run into things. Oops.
Well, it wasn't it Michael that got a gold star for building a building?
A claw.
Ah.
No, a metal building.
Oh, that's right. That's right. For his shed, his man cave, he did.
The building is on the floor.
Yeah.
It's rolling.
But my claw wheels are rolling. Casters are rolling. So that should mean something.
That's right.
I think picking up a plush toy was what the gold star was for.
That was
weeks ago when he first moved into the man cave. We gave him a gold star for.
I remember that. Yeah,
That's right.
I still have it.
Yeah, it's awesome. All right. So let's see. Who else has something that they'd like to show?
I'll show a couple things.
Cool.
All right.
And then I got something at some point, but
yeah. We have the overhead. I got some two new filaments in. One because the wife wanted me to do some pink things. So I'm going to show you off that first because I think that's some neat attributes to it. I've never used Polymaker brand before, so this is going to be something new, and I will report on how it works. This first one right here is you can't really see, but it's white. The packaging on this thing is phenomenal as far as stuff goes. It's almost like an Apple branded kind of packaging. It's really well made. You get a whole big book of stuff on it. And the reason this stuff is in this kind of case, this is PLA and it's called Poly Smooth. It was a little expensive. It was 3/4 of a kilo for like $36. And it's supposed to work like ABS does with acetate, except for this is PLA and it uses nebulized alcohol, the rubbing alcohol, whatever, to help smooth it out. And so you're supposed to be able to do a lot of smoothing with it. And I hear it's supposed to be pretty good. And I ordered it because I'd never used it before, and I really wanted to order the other things. And I'll explain why in a second. So I'll report back on this when I get this going to see how it actually turns out. I know I'm glassing Murray's eyes over with the 3D printing, the religion of 3D printing, but that's okay.
Did you call it nebulized alcohol?
Yeah, basically what you do, as I understand it, is you get one of those misters that people use, and you pour alcohol in it, you put this in enclosed volume, and you nebulize it up so it interacts with the outside of the PLA printed part, and it's supposed to smooth it all out. So
Nebulization is an actual word.
I think, I've not made the ization of it, but
nebulizer.
Cool. It sounds like something you put into a cocktail.
Sounds pretty nebulous.
Medical equipment that used for respiratory therapy. I know that.
Yeah.
So Harold, the other way I've heard of doing that is that you just get like some rags or paper towels and soak them in alcohol, and then put your object inside a coffee can upside down, and just depending on how long you let it sit in there with the.
I didn't think normal PLA actually cared about alcohol or acetone.
You're right. I was talking about the ABS.
Yeah, this is a special version of PLA that's supposed to do that with alcohol. I do have ABS, and ABS will readily dissolve in acid with acetone, and I've tried it a couple of times, and I've got some smooth parts, and I've got some. Let's just say, I need to print those parts again because I left it in there too long. Kind of thing.
All right.
Yeah, the problem I had with smoothing ABS with acetone was to be even everywhere. You really have to have some sort of that mist that it has to be. Yeah. It has to be even. You see, what you'll find is that if you've got like condensation of acetone on the bottom, then you'll have more smoothing effect on the bottom than you have on the top. By the time you smooth the top, the bottom's all screwed up. I mean,
it's a mess.
A convection type of situation that keeps moving everything around, right?
Yeah,
that would probably be the right way.
The technique I found worked reasonably well was to take your paper towel that has your acetone on it and drape it, and that seems to get pretty uniform.
So this next thing here is Polymaker. You'll notice the box is a much different box than the one before. Something called Polyterra, and I got it for a few reasons. The box is a cardboard box, not very much coloring or anything. It goes along with the whole theme of this thing because I got to make the wife Mickey Mouse ears. and she wants pink ones, so I had to order the pink filament, of course. And
So the pink filament comes in a brown wrapper. Huh?
well, yeah, and yeah, it's all closed. It's all closed up, right? So, and you also notice this wheel, the reel that this is on is also cardboard because it is called Polyterra Pla. I don't know if you can read that. Maybe you can read it. I'm going to read the kid.
Yep.
Polyterra Pla. And the idea behind this thing is it's supposed to be more recyclable than normal PLA. It's supposed to print really well. Jury's still out on that. It's $20 for a kilo, which is the same price as PLA that I'm paying down at Micro Center or close to it, anyways. This is a cardboard wheel that can be recycled. The filament's supposed to be more recyclable or will break down better in the biodegrading thing. And on top of it, for every roll of one of these things you buy, they've contracted to a company to plant a tree. So there's been almost 69,000 trees planted so far, according to their website. So I figured that's pretty cool. And I mean, that's about all I got to show. And then when I get to print with this, I'll report how well they print or how well they don't when I get done with it.
That'd be cool.
Yeah, I thought it was pretty cool.
You know how much it costs to plant a tree?
I have no idea.
23 cents.
Well, okay, so they're kicking 23 cents to somebody. It doesn't matter. They planted a tree. That's all that matters to me at the moment. They're planting more trees than I'm planting. I'll tell you that.
That's pretty good.
Yeah, you guys got to watch out with that stuff. Acetone, methanol, ethanol.
Oh yeah,
very nasty
some of that.
chemical.
I went and bought a $20 skillet because the wife wouldn't gonna let me use the one out of the kitchen, and to put some acetone in it to heat it up to do a hot acetone thing to see how well that worked, other than what everybody else has been talking here with the cold where you drop it over. And let me tell you, the butt was puckered pretty good when I started kicking up the temperature on that thing. You know, just because if something goes bad, it could go bad really, really fast.
Just a few more steps away, and you can take on the meth lab. But okay.
Yeah, exactly. Well, nothing bad happened, but it was still a bit, you know. Still a bit
Your own episode of Breaking Bad.
something like that. Yeah.
Learn about these chemical things. I'm just going to stick to blowing up chips and resistors.
Hey, Carl, that reminds me. On the Discord channel, we had a young guy. He's a 9th grader from New Delhi, and he comes from clearly a poor family. And he's been making YouTube videos of his robots, which he builds out of junk. And they're, in their own way, pretty impressive. And he builds stuff out of almost nothing. Like, he's got a couple motors and things. And his name is Arjun. And Kumar's we've all kind of taken him under our wing and trying to help him out. And Kumar's trying to figure out how we can help him. But I have to say that he makes us all look a bit weak, because he's building, kind of remote controlled robots. He wants to be a mechanical engineer and go to IIT. And he's a 9th grader, and he's incredibly he builds like the most weird stuff, but he almost in every one of his videos looks like he's going to set fire to his house. He's got flame throwing robots and robots that fire projectiles and water plants. And he makes really amazing YouTube videos. I think he should be a filmmaker, actually. He uses James Bond music and stuff. And I feel completely humbled by this kid, I tell you.
Yeah.
Did you see the videos that Kareem basically let us know about? There's another kid that's, I think he did a replica of a Tata truck.
Oh, that wasn't a kid. That's an adult. That's
an
adult. That's an amazing. But if you've ever been to India, that guy was making he was using license plates and just pieces of steel junk and stuff, and he built a semi truck. But he had like motors, and he was using some obviously quality control, quality components, but just building it out of junk. Yeah.
I
That
didn't
was
show
amazing.
that one. I'm not the one who shared that initially.
I think I found that one.
But
That's an amazing video. I think anyone should watch that. Honestly, that's pretty impressive.
Basically, I think he had sheet aluminum, and he had some of the standard like aluminum bar frame for like window frames or something, and he just had really good technique with eyeballing stuff and then making things in pairs and quads so that they were matched pieces, but they matched each other really well and came together.
Yeah, he's using hand tools mostly and just a hammer and yeah, I was astounded. I thought it was
Craftsmanship.
pretty cool.
You know, there's a
Sitting
whole
out in the
genre
dirt,
of this
you know?
on the internet. People who basically make things out of junk, and some of them are quite spectacular.
Yeah,
Well, if
I like
anyone's
the
looking
one
to
where he takes his
sponsor a
flip-flop
ninth
off.
grader in New Delhi, we've got one who needs help. As long as he doesn't kill anybody or set fire to his house.
Yeah, I like the one where he, the one scene where he's trying to make like impressions in the metal, and he takes his flip flop off and he's hitting, his flip
Yeah,
with a hammer.
yeah, that's great.
Try to, basically cushion the blow and push the metal, and that was pretty creative.
Very, very creative.
Well, I had one more comment I wanted to make to Chris before we go away this evening. Chris, your talk, I guess it was 2 weeks ago, where you showed us the documentation that you were doing on your robot inspired me. Chris, are you there?
On mute.
He's already gone to bed.
It could be. We put him to sleep, or he's on mute. But
That's all.
cool. We'll catch him again, David. He'll appreciate that because it did look really good. Okay, I'm gonna share something, and then whoever wants to go after me can think about it. I just stumbled on this link, and since we haven't talked about simulators in a while, I'm not planning to do a simulator. But and we've also talked about legged robots, and this just popped up on my radar. So some research place in Switzerland worked with NVIDIA, and they have a simulation where using massively parallel deep reinforcement learning, these quadrupeds taught themselves to walk, and then after that they transferred the whatever the output was, the neural net that it took, and then the robots were able to walk themselves in the real world, much like they could in the simulation. And it looks, I haven't read deep into it, but it looks like they take 4,000 of these little simulated agents, and in about 20 minutes, they know how to walk well enough that one can in the real world. So I thought that was pretty cool. And I'll drop the link in the thing here in a moment.
This is sort of how viruses evolve, right?
Really, 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 really cool.
Yeah. Yes. Yeah. Just what we want. We want robots that can teach themselves to overtake the world. Yeah.
Okay, I'm out of here.
All right, guys. Good night, Dave. Anybody else before we totally break? Nope. In lieu of that, wish you all a good night, good week, and we'll catch you, or a good day, Murray, and we'll catch you all next week. Take care. Bye.